Hi, everyone. My name is Joe. I'm an evangelist for Australia, New Zealand. I'm also, I'm a nerd. So do we have any nerds in the crowd? How many people are actually programmers? How many people would call themselves a nerd? All right, there's a few of us out there, okay. Well, we're going to talk about Agile development today. I'm very happy to say we're co-presenting with ThoughtWorks on this one. I would like to get into the level of technical detail that I wish I could. Obviously, it's a bit of a constraint on the time that we have. But afterwards, we'll both be available. We'll go out to the Solution Expo area. And if you guys have any kind of questions, we're happy to go ahead and answer those questions and go ahead and whiteboard any kind of solutions we can come up with. So, Shishir, you want to start?
Hello, everyone. I'm Shishir. I lead the continuous delivery practice at ThoughtWorks India. ThoughtWorks is a global consultancy firm which has solely used agile techniques to develop software for past 12 years. And lately we've been using a lot of AWS, which is it's an excellent platform to do development. So in this presentation, Joe and I will talk about how agile development benefits from cloud services like AWS. So before we start, let's define what do we mean by AWS and cloud in the context of this presentation. By this definition, by no means are complete. They are just a working definition on which we built up the rest of our presentation. So if I have to define Agile is fast feedback. And that fast feedback is achieved with high level of automation. And to have that high level of automation, we need a very high disciplined team who takes care of deciding what are the things that can be automated, may it be database migrations or one-off scripts, or even the test, what level of automation is required over there. And that's what forms the crux of Agile. I'll pass it to Joe for cloud.
So cloud, in general with AWS, we like to define cloud really in terms of benefits that we provide to our customers. Very specifically for Agile development, when we talk about cloud, first of all, we're talking about our managed services, like our relational database service, for example, or Elastic MapReduce. Then a very important part of being able to do Agile development is the elasticity that the cloud brings. And I think Werner went into plenty of detail with that. And then lastly, the idea is that you have a very low risk. And because we have everything as a pay-as-you-go model, this low risk means that you can try something out for an hour, right? And the cost is quite low. And you're going to see as we talk about Agile development, this means that you can experiment a lot more.
So these are the four Agile practices that we are going to discuss today in this presentation. And as you can see, they appear in the logical sequence in which they should be, like it won't make sense to have continuous integration in place without having automated testing around. And so you first get the automated testing in place, then you move up, start integrating your code, then we talk more about infrastructure and code, and lastly, continuous delivery. Other thing is that each of this topic is quite vast and requires substantial amount of time to actually appreciate the depth of each of the four topics. So here we are going to focus more on the breadth. We'll just scrape the surface of each of the four topics and hopefully give you guys enough information to go look for if you want to pursue any of the practices in more detail. So let's start with automated testing. So as I mentioned in the definition, Agile is all about fast feedback. And automated testing is something that provides fast feedback instantly. May it be unit test or functional. Once you have the safety net of test, you can make a change to your code base and then see whether it works as intended or it has in fact introduced a regression bug. And automated testing is a cornerstone practice. More advanced practices like CI and infrastructure as code becomes difficult, if not impossible, in absence of the safety net of automated testing. And the good news is all modern languages have very mature testing framework. Nowadays you can write tests in English. So, and then comes the type of testing. I like this diagram because it covers all the types of testing the teams generally do and also gives a hint of what can be automated and what are better to be done in a manual fashion. And there are certain set of testing that are just done by tools, like performance testing. So these are the different types of testing. I'll let Joe talk about how cloud helps us in achieving all this different form of testing.
All right. Okay, so testing in the cloud, right? Obviously, we all know there's lots of different kinds of testing. And basically, the different kinds of testing, they're going to benefit a little bit differently from a cloud environment. Kind of on the outside of that is going to be unit testing, right? You can do unit testing in the cloud. You can have a pre-built environment to do unit testing. But for the most part, as a developer, developers want to run unit testing within their own desktop environment or whatever they're using. So that's not going to really benefit quite as much. But as you start to drill in, getting into integration testing that you can automate, greatly through our APIs, where it starts to get really interesting is, for example, functional testing, where you can do end-to-end testings on our managed systems. But what I really quite enjoy in my testing environment is actual accurate performance testing. So what's quite interesting thing you can do is you can bring a copy of your whole production environment up within your development environment through templating and through using the Amazon Machine images. And you can actually simulate the exact kind of load that you would get into production, right? So you think about the power of that if you're a developer. You know that that code change you just made is going to affect your production environment because you actually have a copy of that production environment. And you can create the same kind of traffic that you'd get from the internet. And that's because you can do parallel test execution, right? Because, of course, in AWS, running 1,000 servers for 1 hour is actually the same cost as running one server for 1,000 hours, right? So think about that for a moment. You don't even have to simulate what the traffic's like. You can use, through automated systems, you can actually kick off servers across the world to test and see how your environment's going to react to that. It's a very powerful concept. One of my favorite tools to use that is it's a tool called Bees with Machine Guns. Has anyone heard of Bees with Machine Guns? No? Well, then I won't ask if anyone's used it, obviously, right? What Bees with Machine Guns is, it's an open source tool that was created by the Chicago Tribune. It runs on AWS. It's using Python and Fabric and our APIs. And what it does is it does a distributed denial of service attack onto whatever your website is. Now please do not go home and run this against somebody else's website. Joe is not telling you that's okay. That's not okay. However, it's a really great way to see how you can see how your own website or any kind of web application is going to go under a heavy load. And what that actually does is it uses our APIs in the background, and it kicks off EC2 instances. And these EC2 instances then will spawn up, and they'll attack the application, right? So they'll do a bunch of series of gets or puts or whatever you tell it to do. And then you can monitor the response to your application using CloudWatch through our different metrics. So as a developer, when I make a code change, I can copy my production environment, and I can see if that code change is going to affect production, right? So how many people here has ever written an innocuous line of code, and you find out that it's really slowed everything down? Come on, be honest. Yeah, that's right. I've done it, right? I've done it. But you might not have had a really good way to figure that out, right? So you can test it in your development environment, but your development environment is different from your actual production environment, right? In this type of scenario, when you're able to do agile development and use an environment like AWS, your development environment can be an exact copy of that production environment. Your testing environment can be an exact copy of that production environment, right? The interesting thing, when you get this kind of flexibility, is that you can go from being kind of a developer to an experimenter, right? So a good example of this is I used to have a startup. It was litigation support. And I had a very big database system, giant SQL Server database. And I was putting all this data into it, And guess what happened to my database? It got slower, right? Half of it probably because I was kind of a bad developer, but I didn't tell the people I was working with. The other half was, well, there's a lot of data in it, right? So how did I have to fix that database? The first thing I thought, well, I'm going to put as much RAM in that database as I can. That'll surely speed up that database. So what I had to do is I had to order more RAM from that database. And being very smart, I ordered that from Amazon.com, of course, right? And I had to wait, a period of time to get that RAM into my company. And then I had to take down the system, plug that RAM in, and then I had to boot up the database again. So basically, during that time, I had to take down my whole company. Total turnaround time was about 2 weeks to experiment to see if the RAM worked. And the RAM did work, right? The next thing I thought is, well, what if I do faster disks, right? Because database is doing a bunch of transaction logs on that disk, right? And so I bought a solid-state drive. I had to make sure that solid-state drive was compatible, with my hardware. Same process. Ordered it, waited 2 weeks, experimented, and brought it back up. Now think about if I did the same thing now. If I could go back in time and rebuild that startup using the technology we have available with AWS. I could use our RDS product, our relational database system, right? Relational database service, right? I could take a copy of that actual production database. I could make do another copy of that. I could bring it back up in a new EC2 instance with more RAM. And I could test it right there under load test and know exactly what the effects are going to be. Total time, maybe an hour, right? Or I could do it in an instance that has a high-speed I/O. And I would know under load test exactly how my environment's going to change, right? That's where you start to really see the power of doing an agile type development environment with the kind of structure that AWS brings you. So we'll move on.
Just one last bit around automated testing. Functional testing is slow in nature, and we have seen it on various applications that we have developed. Actually, one of the product that we have called Mingle, the functional test takes 1.5 days to run if it is run sequentially. And the only alternative to get faster feedback is to run them in parallel. And in such scenarios, well, if we had the option of AWS back then it would have been really useful to scale out, run the functional test in parallel, and actually shut down when needed. So let's talk about the next practice of Agile called continuous integration. Now we have written all the tests. We have automated safety net of automated tests around our code base. It really doesn't yield a lot of value if a person is just running it on his machine all the time and not actually integrating with the upstream trunk. And that's where the continuous integration comes into play. Traditionally, it has been seen that people develop software in silos, like there are parallel teams working on different components of a product, and later on during some part, before going for a release, they try to integrate it to get, integrate the software, and they find massive integration problems. Actually, they have integration teams to solve the integration problems. And one of the core tenet of Agile, actually XP, is if it hurts, do it often. So that's where the continuous integration comes into play. It says that every check-in that you make to the trunk should, every change that a developer makes should be merged with the trunk, and all the automated tests should be run on it. And it should be done every time. And that means everybody is developing on a main line. If CI, apart from the tools and all, if you have to think what really CI a process looks like, it's just, you can think of it as a background job whose only job is to pull the repository, pull the changes out. If it finds something new, it builds and tests, and otherwise it just slips. And the typical workflow is a developer checks in the code to the repository. There is some CI tool like Jenkins Go or TeamCity polling the repository. Once it sees the changes, pulls it out and generate reports, runs static code analysis, and sends results back to the user. So now, how does cloud help in the CI server, continuous integration? Like I said before, like you do automate testing and you want the test to run on each check-in to your source code. And also the fact that the functional tests are slow in nature, and also they have to run across different platforms. All these things together, it is very easy to have such kind of ecosystem up in the cloud. And also it gives you the flexibility to scale one set of agents more than the other. Like if I want more Windows agent, I can do it for my regression suites to run on Windows, and maybe lesser on RHEL and Linux box. Continuous integration is a very, it sounds very simple when the application is just one web app or has one or two components. But it can get really complicated when there are multiple components, like 12 or 3 repositories, services talking to each other, and finally you have to deploy everything together to the production. In one of the projects that we are working on, the client has around 16 repositories, and we have around 35 pipelines which run every time a check-in goes in. So a check-in goes and it triggers a downstream build on each of the components. They all integrate together, and finally it determines whether the entire set is ready to go or not. So all such techniques are, there are a lot of techniques as to how you create your pipelines. And this book is a very good read for figuring out, to know more about what are the different types of pipelines you build, how you have your integration pipeline set up and all those things. I highly recommend this book if you want to know more about continuous integration.
It's a pure coincidence that that book is written by the founder of ThoughtWorks. So I don't know how that accidentally made it into the presentation. So how many people are doing continuous integration in their development environments? It's about less than half, right? What kind of CI servers are you using? Hudson? Yeah. Jenkins? Anyone using TeamCity? Yeah. Anything other than those? Bamboo? I tend to, in my own environment, I tend to use Jenkins. I work mostly in the open source software world, although I used to be a C# programmer. And I mean, they're all very good. They all do some of the basic things. One of the great things about Jenkins is it's free. And if you have a startup, free is good. Free is very good. The other thing is it's got plugins for everything, right? I mean, it's got a plugin for almost every language type. And it actually has a AWS EC2 plugin, which is quite nice. So it can scale out as it does all your builds. If I was doing purely a .NET shop, I would also maybe consider TeamCity is actually a very good one too. But that one costs money, and when you're a startup, you tend to be poor, right? Sure. Yes. So the question was that you run a CI server right now, but you're running it within your own environment because your team's in one place, right? So, I mean, the one great thing, okay, so with the CI server, if you run in the cloud, there's a couple things. First of all, if your project starts to get bigger and your code base starts to grow more, the CI server is going to tend to get slower and slower because it has to run more and more tests, right? The nice thing is if you're running it within a cloud infrastructure, what it can do is it can actually build off parallel building agents. And so the return time is actually going to be the same. So as you run more builds in an environment like Jenkins, it's going to reach out to EC2, it's going to spin up a Jenkins slave, and it's going to be able to compile stuff. That's one of the good advantages of it. The other advantage is well, it's going to be globally available. So if you do ever have a team that's outside your environment, it's very easy to give them access to that CI server. You can also replicate it. So once you have that project done, or you have another project that kicks off, you can replicate your whole CI system. You can turn it into an Amazon machine image, and you can relaunch that as a new CI server. So there's several advantages to be able to do it in the cloud. It can, be in your case that running it within the desktop environment is a good, suitable solution for now. So I'm going to talk a little bit now about infrastructure as code, and I love it. I love infrastructure as code. I'll just grab that at the end, just so we don't run out of time. All right, but you can grab me afterwards. No problem. What do we mean by continuous integration? We mean programmatic provisioning by API, right? What's the really cool thing about that? Everything within AWS is programmable. Everything we've shown you today on every single one of these tracks, you don't have to use a UI, and you don't have to have a person to do it. That means your entire infrastructure can be provisioned by an API, by a command line tool, by interacting with our SDK. And why would you want to do that, right? Why do you care? Well, as you move from this manual process, you start to move up this arc so that you get from manual to scripted. So now you're running a bunch of scripts that are actually able to provision your environment, maybe install your web server, connect things to your load balancer, set up your database. Eventually, you move to this higher end of this arc where everything is programmatic, right? What does that mean? You're going to get speed, reliability, repeatability, and you're going to reduce risk. That means everything in your infrastructure is actually going to go through the CI server, and everything is tested. That script that configures your Apache web server, that script is version controlled and tested, right? That script that creates the EC2 instance is all tested. The EC2 instance itself can be an Amazon machine image, which is produced from this code from the CI server. You're guaranteed that is the exact same instance that you run in your production environment. And so you get some very interesting things that come out of that. When you look at automation, there's basically three levels, right? You got the infrastructure level, and that's where we talk about Amazon Machine Images, right? And we've got different tools that you can use and you can create that. I actually have Jenkins create my Amazon Machine Image. When you move up that code, you start to get into where we get the Puppet and the Chef environment, right? Has anyone used Puppet and or Chef, right? They're really good tools, they're open source tools. I tend to stick to the Puppet side because I find it's quite a bit easier, right? And I use a Puppet to actually create my environment within my EC2 instances. And then, of course, you have your actual application, which might do a bit of bootstrapping. One great tool that we've got is something we call CloudFormation. I think it gets a bit overlooked. It's one of my favorite tools, right? It is an orchestration service, right? In a very simple JSON format. It's declarative, and it allows you to create and manage different resources in a dependent order. That means you can script out your entire production topology, check it into Jenkins or Hudson or Bamboo, or I'm sorry, to different source control and go through Hudson and Bamboo and Jenkins, and know that it's going to create that whole environment exactly the way you want to, right? So that has some very interesting implications now. If your whole environment's in source control and your whole environment goes through test, what does that mean? That means that your operations team and your development team and actually, your IT team are now all on the same team, right? Because it's a very interesting shift is going to happen now. You're actually programming your entire production environment. One of the reasons I quite like Puppet is it's idempotent, right? So the great thing about Puppet is you can declare exactly how you want something installed, or what you want installed, but not how you want it installed. For example, in this case, we'll install the NTP package. And Puppet will take care of it, and it worries about the underlying operating system. But because it's idempotent, you can run it over and over again, right? So how many people have ever had something crash in production because maybe a developer logged into the production system, maybe he looked at the web server log, and it changed permissions on the web server log, right? And what does the web server do? It crashes. I have done that. I have been that guy, right? If I use a system like Puppet, I could run that Puppet script again, and it would go in there and it would make sure that environment is exactly back to that pristine state that I expected. So it would actually go back and change those file permissions, for example, right? That guarantees that everything's reusable, right? It's a very powerful tool when combined with the AWS APIs, when combined with continuous integration and these agile techniques. So let's go on to talk about continuous delivery, the ultimate ability of the agile developer.
So now, we treat infrastructure as code. We have testing around our code base. What does that give us? It gives us confidence that every time I'm making a change to my infrastructure or to my code, if there is something breaking, the suite of my automated tests will actually catch it. And that means I would not be afraid to put that release out to production once it passes the set of the automation tests around the infrastructure and the code. And that has been the biggest challenge so far, like the last mile. In Agile, people have been doing like rapid cycles, they do till the showcase, but still the release somehow evades them. Like it's still 3 months, 6 month cycle before a product, from the moment we start development till it goes to production. And that last mile is mostly because of this fear of something breaking because we don't know how the production environment looks like. And also we want business to have the ability to put the software in production whenever they need. This should not be tied with the operational constraints of, oh, my ops team is right now, doesn't have the window to put this release out. If we have a tight suite of automation around our infrastructure and code, and if we promote the same artifact that we have started on the CI up till the production environment, like that same artifact gets deployed to UAT, then up to production, then the chances of failure is less. Also, since it is version controlled, you know exactly what's going in. So auditing is easy. Also, rollback is easier because you are testing the up and down scripts every time you are deploying it to a higher environment. So that gives you always a production-ready software. You actually prioritize releases over features. And that's what continuous delivery is about, that you keep your software production ready always, and you should be able to deploy it on demand with a push button kind of mechanism. And it's not something new. Like, there are people doing it. Flickr does it. Flickr does multiple deploys to production multiple times a day. We at ThoughtWorks, of course, don't deploy that frequently for our Kai, but we always keep the software at a state where it can be deployed by a push button. And that window you can decide. Like, it doesn't have to be it's not continuous delivery if you are deploying every commit to production. It's more about when I want to go to production, there should not be something stopping, or there should not be any ceremony required to get your software to production. How does cloud help in this? Traditionally, software gets deployed to a data center, and what you have to do is you have to take down the production system, put the new binaries up, run your sanity checks on it, and then decide whether it's good to go or not. People took it one step further. They had two sets of production hardwares, which is actually called blue-green deployment. And what they do is they deploy the new code in a cold environment. They run all their tests, and when they're happy with it, they actually flip the switch to the new environment. Now think how easy it is to do it on a platform like AWS. Everything is scriptable in AWS. Like, start from, if I have to spin up an environment, it's an API. I can spin up the entire environment, deploy my app to that environment, run the smoke test on the new environment, and when it's done, I just change the switch on ELB to point to the new environment and take down the old. Again, this is also a very, very detailed topic and has many scenarios in which you will need to do different kind of techniques and patterns that you might want to use. And this book is a very good, it talks about all the techniques that are required to keep your software always production ready, and for deployment practices like blue-green deployments, canary releases, and things like that. So I highly recommend this book. It's again written by my fellow thought worker, Jez. So with that, we come to the conclusion of the presentation. So what we saw is automated testing benefits from elastic computing and pay-as-you-go pricing model, continuous integration. If you're hosting on AWS, then you use all the three services. Infrastructure as a code, of course, you write AWS services, Puppet Chef, you need Puppet scripts over there. And finally, continuous delivery is nothing but a collection of all these three practices and take it a one step further of promoting the same build up to a production. So it benefits from all the three pricing models. Yep.
Yeah, there we go. So, there we go. So, unfortunately, we don't have a lot of time. I've done a lot of agile development. I've been a Scrum Master. Anyone here using Scrum? Do we have Scrummies there? Fantastic. So what we'll do is we have a great presentation from Intel. They're going to talk about big data. But we'll head down to that Solution Expo. If you guys have any questions, happy to set you up, show you how we do agile development. I have several agile development environments I've set up, both using .NET and Python. So I'm happy to talk to you about that. And thank you very much for your time. So we'll just be right back out there.